Hi everyone. So my name is Kwame Manu, and this is going to be an exciting session, a deep dive, introduction to data science and analytics, what it's about, what all the fuss is about. And for the second section of this awesome class, we're going to do something practical. I'm going to introduce you to artificial intelligence, particularly NLP, natural language processing. We're going to work on some data. We're going to program in R and to be able to do some sentiment analysis. And yeah, it's really going to be exciting. I hope you stick with me. Yeah, so basically when we talk about data science, it has everything to do with data. Okay, so data is being generated at an accelerating rate. Everything that we do now generates data. Even your heartbeat is data that is being analyzed somewhere. Okay, so with all this data, we need to be able to understand, derive patterns, make predictions, and all of those things. So that's what data science and analytics basically is about, and it spans across several fields. Okay, it's in health, it's in agriculture, it's in transportation, it's in sports, it's in every single field. Okay, so let's quickly move on to the types of data analytics out there. Okay, so we have quite a number of them. We have descriptive, we have diagnostic, we have predictive, and we have what as well? We have prescriptive. Okay, so let's see what each of them means. So descriptive, just like the term says, to be able to describe some things inherent in a particular data set. Okay, so when you work in probably an organization, a business, anywhere, descriptive analytics sometimes touches a lot on KPIs. Okay, so KPIs are key performance indicators. Okay, so how much units have we sold? How have we grown by? How many branches have we added on? Okay, so these are key indicators that the business sets at the beginning of each business year. And you describe, data that comes in. Okay, so how many units were sold, if it's e-commerce, which section of the store sold the most. Okay, those kind of things. Okay, and if descriptive also goes into sometimes web analytics, digital analytics. So you talk about page views, how many page views have we had this month, unique visitors. If you're talking about agriculture, how many crops have we sold? Like if probably I worked in cocoa board, how many years of cocoa have we sold this year? And all of so that's what descriptive is. You are describing the data, okay, and it relies on past data, past performance, historical data. Okay. Now the next one that you see there is diagnostic analysis. So it helps us understand why this happened. Okay, so why did we sell less units this year? What happened? Okay, and it helps us to identify basically anomalies in the data as well. Are there inconsistencies? Are there unexpected changes? Okay, so try and find those relationships as well and help. And we use basically statistical techniques to be able to understand why these things happen. Okay, so from there, so once you understand what happened, you move on to what we call the predictive analytics. Okay, so predictive is what will happen in the future based on past data. Okay, so based on the trends that we are seeing in this and that in the past, we're able to predict what is likely to happen in the future. And that's what is a lot is happening a lot in sports now, what we call the odds. Okay, so they crunching a number of numbers and they tell you this team is going to win. Sometimes they go as far as, by how many goals and all that. Okay, and it relies a lot on techniques like neural networks, decision trees, regression, and all those kind of things. Okay, so predictive analytical tools, they give us valuable insights into what may happen. If you have the power to tell what will happen in the future, imagine how important you will be. You'll be indispensable, right? So come to you, tell you what will happen in the future. Please crunch those numbers. And then it happens a lot in the on the stock market as well. People use, machine learning models to be able to predict the future. Okay, and then we have prescriptive analytics. Okay, so it helps us answer the question of what should be done. So by the insights from the predictive analytics, you can make data-driven decisions. Okay, so when you work in a business, it helps the business in terms of one sense. So let's take Vodafone, for example, or any other telco, right, for that matter. You'll be able to use prescriptive analytics to determine which bundle to give a customer based on their past usage, okay? So based on what you do, be able to prescribe bundles that suit your needs perfectly, okay? I'm confident I've dealt with this very well, okay? So analytics use cases, man, there are lots. Like I said, we are in almost every field, okay? Self-driving cars. All right, so if you are amazed by this and what Tesla and all the other self-driving cars are doing, it's heavily reliant on AI, so artificial intelligence, machines being able to interpret their surroundings, okay? And it's something that was birthed by Alan Turing. You guys should go and watch the movie, The Imitation Game. It's a story about him. The guy was castrated because he was homosexual. I mean, I'm not, okay, let me end it there. But the point was he went through a lot, right? But he's the father of modern computing, okay? And he bears the concept that can machines think on their own, okay? And there was the Turing test where you sit behind a board and then you ask questions to one person and a machine, and then you tell which one you think was the machine, which one you think was the human being, okay? So it was just to help establish that machines can do things on their own. So yeah, the guy sitting there, I'm sure he's scared as hell. Yeah. So another analytics use case is something that we do here at Vodafone as well. Most of you have heard about Made for Me. So Made for Me is a machine learning backed product that we pushed out there. So based on your usage in the past, based on your pockets, your 1 CD, your 2 CDs, the machine learning model recommends products for you, products that it thinks you can take, products that will be beneficial for you based on what's in your pocket, okay? And then there's fraud detection as well. So using machine learning models, you're able to automate the process based on past activities of fraudsters and all that. You crunch all those numbers in, and you're able to identify similar behaviors and pinpoint and catch people. Okay, so let's go through some steps involved in data analytics. Okay, so the first step is to determine the data requirements or how the data is grouped. Okay, so once you know the data that you need and you're able to obtain it, you're able to segment it, separate it by various categories. Okay, the second step is now that you know the requirements you need, the kind of data you need, you go through the process of collecting that data, okay? So with the text analytics that we are going to do, you know what you want to do. You want to analyze text. So the next step is you look for the data, you go and collect the data, you go and obtain that data. If you want to do social media analytics, you go to Twitter, use the Twitter API to extract that data, okay? So the next step is now you have the data. What you need to do, you need to analyze the data. That's where your data science or analysis skills will come in, your SQL, your Python, your R, your statistical knowledge. That is where your visualization, that's where all it comes in, okay? And you need to clean the data before analysis, okay? So once you clean it, and cleaning data is such humongous work, okay? So we expect it as you roll through this field. You need to spend a lot of time cleaning and navigating the data and making it ready for analysis, okay? Now, so we have data scientists and we do have data analysts. Basically, data analysts move from the analyst to the scientists. So this was just to help you understand how these two differ, okay? So data analysts eventually evolve into data scientists. Data scientists basically rely more on machine learning models, algorithms, and statistics to be able to do prediction, to be able to do prescription, okay? Data analysts do more of descriptive, okay? So they rely on the historical data and then try and give you insights on it as well, okay? So, I mean, just more emphasis on the difference between the two. I mean, they share similar things. You need to be extremely curious. You need to derive insights from data. Data itself is boring, but you need to communicate it to people who don't understand what you are talking about. So that's where your communication and your visualization skills come in, right? Excellent. So into the data science verse, okay, so data science, as I mentioned, is basically advanced data analytics or data analyst rules, okay. So they rely heavily on machine learning model. So an analyst will be doing more of business administration, exploratory data analysis, all those things. And then you zoom into the data scientist role. So the data scientists will do some of the exploratory analysis, pardon me, but they do and delve more into machine learning and advanced algorithms, okay, data product engineering and all those sorts of things, okay. So this is more of a life cycle to help you understand the process of a data and science role. So you do your data capture, as I already mentioned if you were listening, okay. So how you obtain that data, and then when you capture the data, you need to maintain it's more like store the data somewhere. So that's why you have the data warehouse and data cleansing, data staging, processing, and architecture. Okay, and then now that you have the data stored, you need to process that data. That's what we call data mining. SQL is very important in this field. Okay, it's a skill that you need to pick up. Okay, clustering, classification, data modeling, and summarization. And then now you need to analyze the data. So that's where you see what we are going to do. Excellent text mining. You do your regression, qualitative analysis, and all. And then a field that most people do not really pay much attention to, but communicating the data is very important. Doesn't matter how your model is a 20 million lines long. At the end of the day, you need to communicate something that the business will understand, not your fantastic machine learning algorithm. Okay. Yeah, I'm just, so remember what I said, more prediction and more machine learning for data science, while it's more descriptive and predictive for data analysis. Okay, so let's just move on. And like I mentioned, right, data analysis, data science, it's in every field. You see here, we have travel, marketing, healthcare, social media, automation. It's everywhere. Okay, so it's a very broad field. And once you're able to master it, you're able to apply it to so many areas. Okay, so I mean, for all those coming in, I do wish you the best. If you take your time and put in the effort, it will be totally, totally worth it, right? Okay, so then let's move on. So then there's also another field that we call the business intelligence field. So business intelligence and data science work together. Okay, so BI guys work more with the SQL, data warehousing and all that. But data science goes beyond that. So whilst BI will focus on structured data, data science will do both structured and unstructured data. Okay, so like logs, cloud data, XU, text, like all sorts of data, right? And BI will focus more on statistics and visualization, but data science delves into machine learning, graph analysis, NLP, right? All of those things, okay? And this is a fantastic look into it as well. So whilst BI is looking at past and present, data science is looking at what? Present and future. Okay, so the tools as well. Yeah, so let's move on. This is just the broader field of AI, machine learning, and deep learning. Okay, so artificial intelligence is the wider field. Machine learning is a field that sits inside of AI, and then there's a deep learning field as well. So I don't know how many of you have some knowledge into what these three are. So let's take more like a graphical or a timeline approach into this. Okay, so artificial intelligence was what was birthed first. Remember, I talked to you about Alan Turing. Okay, so how to be able to tell if there's any intelligence in machines. Okay, so can machines think on their own? Can they challenge us? Okay, and all that. And then machine learning came into the field. So machine learning is more like training machines to be able to learn from past experiences and make decisions on their own. Okay, and deep learning is something that's coming up. Okay, it's a much complicated and deeper field, but let's just skip this. Right, so let's focus on what will be relevant to us today. Okay, so that's AI, natural language processing. Okay, so NLP is a branch of AI. Okay, that helps computers be able to interpret our natural language. Okay, so the examples I give is You know, you've heard about Siri, all the voice assistants, Alexa, Bixby, you know, all these guys. It's all because of NLP, okay? So they've been able to understand what you say. Siri, what is the time today? Siri, who has won the US elections? If they're able to understand what you're saying, interpret it, and give you a response, okay? And other use cases is sentiment analysis, which we are going to do, information extraction, and all that, machine translation, okay? So Google Translate is another perfect use case. You know, Google Word, when you make mistakes, it's able to identify it and correct you. Microsoft Word as well. And then we have something that we call the IVR. So when you call Vodafone, and then it tells you dial one for this, dial exactly. That's also another use case. And as I mentioned, all the voice assistants, which was birthed by Apple with Siri 2011, and then Cortana by Microsoft in 2014. Alexa was also birthed in 2014 by Amazon. Then Google came with OK Google in 2016. I just said it on my phone later. And then we have Bixby by Samsung in 2017. Hey, Samsung. Okay. Right. So let me touch on another concept, big data. Okay, so you've heard of Hey, please. Google is okay. I was just illustrating something. Right. So big data is a term that has been going on a lot. Okay. So it's called big data because it refers to data that is so large. Okay, that you need special systems to be able to store and process them. Okay. So let's look at these 4 V's by IBM. So big data, to be able to classify something as big data or characteristics of big data, IBM has these four V's of big data. So volume or scale of data, okay? So big data is data that is so large, right? So imagine we have 6 billion people with cell phones. The kind of data that they are generating is what we call big data. The kind of data that's been generated on WhatsApp, the kind of data that's been generated on Twitter, that's what we call big data. Large volumes, extremely large volumes of data, okay? So 40 zettabytes of data will be created by 2020. An increase of 300 times from 2005. We have 2.5 quintillion bytes, so that's 2.3 trillion gigabytes of data created each day by internet users. I'm not going to blow your mind. I have even more stats at the end of this to excite you. So that's one, the volume, that's the scale of data, and variety, different types of data, social media data, YouTube, video, various kind of data, your Fitbits and all that. And we have veracity. Veracity has to do with the uncertainty of data, and something that we deal with in business. The data that you have, can it be trusted? Is it reliable? Okay. And also velocity, the speed with which we are collecting data, or data is generated every day. Okay. So we've gotten to an exciting part of this presentation where we are going to do our own text mining, text analysis, and all that, right? So before the class, I indicated that you have the R Studio setup. I'm not sure how many of us have that, but if you don't, it's fine. We are going to go through that. Okay. Right. So R is a programming language that's maintained by an international team of developers. Okay. So it's just a bunch of people that sit around maintaining it. Okay. So it's not for profit or anything. So if you go to their website, you will be able to download that. Okay. So let's quickly do that. So when you go to the comprehensive R archive network, right? So once you head there, you'll be able to download R. Okay, so R is not like Microsoft Word where you just download it and you start programming. Okay, so you need to download R from here. You know which one to do, whether it's in Linux or MacBook. So once you download it, you need the studio, which is the IDE, the Integrated Development Environment, where it's an interface where you're able to run your program and have it compiled and all that. So for that, you go to our studio. So you just go to our studio download and you have that downloaded for you. So once you go there, you're able to have it, and it's all free. Okay. And previously, I was one through a Unix terminal, like, matrix, all those complicated green numbers with the black background, right? Yeah, until, in recent times, you have very nice IDEs like RStudio. There are others like Film, Emacs, Sublime Text, plus there are robots. There are a lot of them, right? So once you have that set up, I believe we can just go ahead and so this is the RStudio. So you have where you run your script, you have your console, and then you have where your plots, pop up, and then you have your environment here as well. Okay. So as I mentioned, we are going to work on data. Data is more like a Bible data, being able to derive insights. Okay, I hope you're excited because I am, but it's going to be fun. So I got the Bible from the Scroll Mapper. Okay, so once you come here, it's on GitHub. You're able to see that. So you just go to CSV version and then you download all the versions. Which one you're interested in? So let me show you how it looks like. So yeah, that's it. So that's it, the Bible here. So whilst it's opening, there are a couple of libraries that we will need specifically for this exercise. Okay, so let's run through them quickly whilst this is opening. So one library you are going to need is the tidyverse library. Okay, so the tidyverse contains packages that are very necessary for everyday analytics. Yeah, so that's basically the data. So the data should sit in the first column, right? And then make sure you have a heading that you take note of. Okay, so that's basically about it. Right, so I was telling you about the libraries. Okay, so we have the tidyverse library. And I mentioned it contains some very important packages like ggplot2. So ggplot2 is for visualization. Okay, and then it has also deep layer. Deep layer is for manipulating data. It allows you to do a lot of things like mutate, select, filter, summarize, arrange, a lot of things, right? So once we're able to install the tidyverse package, we should have all of this in there. There's also another package called the reader. Reader allows us to interpret data like CSV data. So like the Bible we downloaded in CSV format, we'll be able to read it. Okay. So let's go ahead and install the tidyverse package. So it's just a simple command of install.packages, right? And then inside here you have the name of your package, which is tidyverse, right? So once you have your tidyverse, you can press Control Enter to run it, or just click here to run it. I hope you're good. If you're good, then let's move on. So I run it. Okay, sure. I want to restart, no problem. So once it restarts, I give it some time, and then it installed my packages for me. So once your program runs here, and then you see this red button, it means something is happening. So just give it time whilst it compiles and runs the program. Okay, so hope you guys are following, right? Should be fun. At the end of the day, you should have done something really practical, something that you can, try out on other data sets. Okay. So another package that you need to install is, I was just typing in the console. Another package you need to install is tidy text data. Okay, so let's run that as well and see. So once it's running, let me explain to you what the tidy text is. So the tidy text is a function that allows us to tokenize our words. So let me explain further. So let's take a sentence like Liverpool is the best team ever. Okay, so this is a sentence that has some words in there. Okay, so when you tokenize, you split them into individual words, and it allows you to do further analysis. So when you take a book like Harry Potter, you want to see how many times Harry Potter is mentioned in there, or Hermione is mentioned in there. if you have the text version of that data, you're able to tokenize it and split all the thousands of words into individual words, and then you're able to count and see how many times a particular word was mentioned. Okay. So that's the excellent use of the tidy text, and something that's going to help us in our exercise today. Now, the last package is something that we call the word cloud. So I don't know if you guys know what word cloud is, but I'll show you once. So whilst it's running, let's go and look at what the word cloud is. So, yep. So this is a word cloud, okay? So this is just text that you've been able to transform and beautify it and make it look more appealing, okay? So it works on the tokenization. So once you tokenize the word, you know the count of words and which one have more prevalence. Once you create it into a word cloud, the words that hold weight will show the biggest or with the brightest of colors, okay? That's an excellent explanation, right? Yep, I guess. No, I think so. I don't guess. I think it's an excellent explanation. So now that we have all these packages, so now let's load our library. So our first library will be what? The tidyverse library. Oh, spelling mistake, right? Have I made a mistake? Oh, I said library and added library. Okay, no, we don't. Okay, yeah, correct, got it. So the next library will be what? Tidy text. Yep, excellent. So we have it loaded. And the next library is what? Yeah. So once you really hear, even with the loading of the tidyverse library, you realize that all the other libraries have been loaded for us. So we have the tidyverse table, tidy reader. Let's load that. So tidy text is done, right? Okay, excellent. So let's read word cloud library. I think, yeah. Let's do the word cloud. Excellent. Let's add 3 more. Let me do the text mining library. I want to add the snowball library. I'm not sure we might use it, but let's see. If there's time, we might use it. And then the last one is the color blue. I will help us with the word cloud be able to blue color. Right. So let me do the word cloud. Excellent. TM. Excellent. Snowball C. Excellent. Color blue. Excellent. Right. So the first thing I'm going to do is review data. Okay. So review data means you need to define a path to where your data is, so that your data can be. So we'll be assigning something to review data, and to do that you assign using these two symbols. Okay. So you are saying I want to assign some data to you, review data. The data is what? CSV. So read.csv. Now we need to identify what the data is, and the data is here, which is the text.csv. So we copy the path. Okay. So in code, we put our path here. Right. So once we have that there, we are almost on our way. Okay. So a bit of a history lesson for you. So Unix introduced a forward slash character, that's forward slash, okay, as its directory separator in the 70s. Okay. Now remember that I said that we used to be programming in Unix. Okay, so it's taken after Unix's forward slash as a directory separator. So this is a directory, desktop is a directory, from desktop, analytics, another directory, so on and so forth. Okay, now Windows uses a backslash because by then they didn't have directories, or they weren't using directories. So the time they decided to use directories, they had already assigned the forward slash to something else. So then they decided, then why not use the backslash since it's simple? So right now we need to change the this to forward slash. So once we are done with that, we need to define the data. So that's T, sorry, plus T underscore AJV or CSV, right? So once you have the path identified, there's two, you need to add some conditions, okay? So remember I said you need to move the header of the file, okay? So that the text knows that, okay, there's a header. So the header is true, which we already noted in our head. So header is true, and then string as factors. Right, we don't want it to convert it to anything else, so we just say false, leave it as is. Once we are done, we run it. Excellent, the data is red. That's what you see here in your environment. Okay. So now, what do you want to do? You want to see the data. So we say is view what? Review data. Right? I hope you are following, guys. I mean, I wish I were in the same class with you, but once again, thank you, COVID. But yeah, I hope you are following closely. So if you want to see the data that you just assigned to review data, you just type view review data, and yeah, you see all of it. Now, one exciting thing is, you know, Excel can only handle about 1 million and something rows of data. Sometimes when you work in businesses where you handle large sets of data, sometimes your Excel will have more than 1 million rows. But once you open with Excel, Excel will truncate it and just give you its limit, upper limit up to that. R can let you view as many rows as possible. So with just a few commands that we run now, we'll be able to see every single data in a large data set. Okay, exciting. So now let's move on to the tokenization. So what we want to do with tokenization is split all of this into individual words. Then we'll be able to see how many times Lord appears, how many times each word appears. Okay, so to do that, follow me closely. We'll do, let's use a new name, tidy data. And then the review data that we have, that we are assigning to this time data, we'll do some processing on it. Let me say. So there's something that we call piping. So piping allows you to do that. So once you pipe it, it gives you an indentation. And now we're saying that what functionality do you want to do on it. So we say we want to tokenize. So tokenize is units. Tokens, to break it into tokens, into individual words. So word, and then we say the head is what? The name of the first column is what? Text. Excellent. So once we have this, it does this feel like to tokenize it. Amazing. Right? So once you tokenize it, you want to see the fruit of your labor. So let's just type view, and then you say what? Tidy data. So now we have words linked into individual ones. In the beginning, God created. Right. So that's how tokenization works. Okay. So that's exactly what we wanted to do. Now we want to count. Okay. We want to count the frequency. Okay. Now in your environment, see total number of words 789,668. So that's the number of words in the Bible. Incredible, huh? Right, so now we want to count. So let's use a new assigned value. So word count. And then we say ID data, right? Am I right or wrong? I'm right. And then we say count. What are we counting? The word and then sort. True. So we are sorting because we don't want it to appear in random. And when you sort by default, it gives you an ascending, descending order. So excellent. So now I want to view the works of our labor again. The fruits of our labor, sorry. View word count. Voila. Right. So the most used word in the Bible is there, and it appears 63,000 times. And then the Lord I was looking for is here, 7,830. Okay. So right, that like that, my curiosity is satisfied. Now imagine we didn't have this programming language, we didn't have this functionality, and I wanted to know how many times the Lord appears in the Bible. All the best to me, right? How long will it take me to count that going through the Bible, right? So that's exciting, right? So now that we've done the count, let's do the sentiment and then plot it. Okay, so I hope you are following me closely. Right, so let's do the sentiment word count. And we do our assigned value. What's happening? Word count. Do assigned value. And then we say tidy data. Yep. Then we do our pipe again. Once we have our pipe, now we're saying that we want to inner join with the library that allows us to generate sentiment. Now there are several libraries. Okay, they have NLP, Ping, etc. But what we're going to use is what we call the Ping library. So it helps us by looking at the word. So if it's based on the word, it gives you whether it's a positive or negative word. Okay, so we're going to see it happen live very soon. Okay, so once we have that, then we count on the word according to the sentiment that we want to establish here. Okay, and then once again, we want to sort it. So when I say sort, what comes next? True, according to what is descending order. Fantastic, right? So let's run this. No errors. Wow, I'm doing really well today. Programmers know, Charlie. One error because of one letter. Charlie, but we thank God for today. So once that is done, now let's go and do visualization. Okay, so I need you to pay attention. This is going to be a long block of code. Right, so let's start with our word count. Now, this time we are not going to assign anything because we are just doing a visualization. Okay, so once you have your word count, what your visualization will be on, you do your pipe. Then you see just visualization. Okay, and let's do our pipe again. Once we pipe that, then we say filter it by sentiment. So I'll show you something to how you can comment out, and then once you comment out, be able to show whether positive or negative sentiment and all of that. Right, so I'll show you something as I mentioned, filter sentiment. So comment it out and see whether positive or negative or whatever. So let's do positive now. Yeah. So we'll do negative and we'll do both, like no filter. Right? And you see how that turns out. Okay, I'm even excited myself. I hope you're excited. And then one other condition you do is the top number of words I want to show. So you can regulate it top 15, top 20, top 100. Let's do top 20. Pipe again, or pipe. So once we pipe it, our next condition is to ungroup it without any values. So let's pipe once again. And then remember the player, you can mutate select blah 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 comes in here. So we have to reorder the words according to the sentiments that we are plotting by word. And yeah, then we pipe again. Okay. So some of they follow a template or a syntax. So once you learn and you get better, you don't need to struggle much to be able to understand how the syntax works. You follow it. Okay. So now ggplot, awesome ggplot comes in here. Okay. So ggplot. Aesthetic, AES is for aesthetics, okay. And then the word and yeah, fill is equal to sentiment. Yeah, they're filling my sentiment. So yeah. Okay, that's it. And because ggplot is an environment in its own, we don't pipe, we add another condition. So the other condition is geometry column. Yes, I want to show legend. So let's show legend and then let's say true. Okay. So once we're done, let's add another condition and see what's up. So facet wrap, I don't know how. Okay, so when you facet wrap helps you, I don't know, fix it well or something. I don't know how to explain that.
Usually, when you type it on the command, it gives you the explanation. Okay, wrap cell 1D sequence of panels into 2D. This is generally a better use of screen space. Aha. It's nothing here. It's just to make it look okay, like it's saying here. Okay, because most displays are roughly rectangular. Okay, awesome. Cool beans. Right. So once we have the facet wrap, then we type sentiment skills. Is equal to, I think it's 3y. Yeah, 3y. So I did. So I'm hoping I don't get any errors. Let me check again. Facet wrap sentiment skills. Yeah, but if there's a bug, actually we'll fix it. That's what this thing is about. Yeah. So another condition is labs, defining which column does what, or what data sets with which column. So wait. So I'm showing legend. So let me legend name contribution. I want the contribution to sentiment. What did I give the X column? Let's see. X column no name. If I think of something, we just put it there. Yep, that's it. So code flip. Yeah. So fingers crossed. Let's run this and see why error has come inside. So yeah, let's I know that already. Yeah, so we are assigning the sentiment to positive, not saying it is equal to. So I said yeah, so it's supposed to be double equal to, because we are assigning it, we are not saying it's equal to, right? So yeah, fix it. Yeah, definitely. So once you have the positive sentiments, you're able to tell the frequency and how relevant it is. So great, good, like holy, heaven, peace, and all that. Okay, so we can as easily as send changes to sentiment, run this, and we see the top negative words in the Bible. Nope. What happened here? No, run this for me. This. Exactly. Oh, ooh, see what I did? I typed sentiment again, so negative, right? Yeah. Yep. So these are the top negative words. Evil, of course. Evil is all around us. And sin, hey, brother, sin is also up there. And fear, wow. Okay, hey, death. Charlie, now it's okay. Let me switch back to the positive. Or let me teach you what I said I'll teach you. So if you want to comment out, so just do a hashtag. So what I expect this to do is to give me both positive and negative side by side. Perfecto, right? So you're able to see all the positive and negative values, and they are relevant, okay? And based on the frequency, that's why we did a count as well. Okay, so excellent work, guys. Clap for yourselves if you're able to do this. Right? So the last bit before the day is over is to create a word cloud. Okay, so let's do that on the typing data that we did, right? So you realize I'm doing a lot of tabs. So because it was an ID, it knows all the things I've done in the past. I don't need to type everything, and it makes it fun, right? So we type again and count word which will be used for the word cloud. Like I mentioned, the word cloud is based on the frequency of the words. That's what gives it the values. So with word cloud, so word cloud, and then we do word and words equal to the colors. So we see color round palette, color round palette, and then the blue one. That's let me take the 9. The 9. Let's do blues. The blues are doing wonders of late. Okay. Let's say 32, right? Just follow me there. Don't understand. Just follow me. It's color brilliant, so just trying to. You see that thing in, is it PPT or Word where the color is a one color, but it's not the same. It's not uniform. It's deep somewhere and light somewhere. That's what I'm trying to do with this. So let's see. Hopefully, I don't do error again. If I go grab, so figure it out. So yeah. So yeah. So you can assign the maximum words. Okay. So let's do 50. Okay. Let's see what happens here. No error. Clap for me, right? So that's what you see. You see some of the words are lighter and deeper and all that. So you can change this to 100. And let's see what we have. Yeah. So, I mean, I hope this has been exciting. You can go back and forth, run any column, any block of code to have your results and all that. I hope this has been exciting. So what I would indulge you to do is to go and get any sort of text data and try this out. Sentiment analysis. When you're done, post it on LinkedIn, post it on your GitHub repo, okay? Have fun with it, explore it, just delve deeper into it, okay? It's all fun. And this is just a few blocks of code that helps you to come up with some insights with a bunch of text. So before I sign off, there's some data that I wanted to, just some exciting fun facts that I wanted you to just as to go through before I sign off. Okay. So if you are getting into data science analysis, know that the future is really, really bright for you. Data is always going to be around us and it's only going to grow. Okay. Now the big data analytics market is set to reach 103 billion by 2023. That's a lot of money in there, okay? And poor data quality is said to cost the US economy as much as 3.1 trillion. Now, US is not the only company, the only country in the world, okay? So with your skills, you're able to contribute to a lot of savings anywhere you find yourself. Now, regarding data that's been generated, in this year alone, everybody generates 1.7 megabytes in every single second, right? And cumulatively, all internet users generate 2.5 quintillion bytes of data each day. Okay, now this is an amazing fact that I saw that really excited me. Netflix saves $1 billion per year on customer retention through big data analysis. Okay, so with their machine learning models, you're able to do those product recommendations based on what you viewed, your interests, and all that. It's able to give you the series that you're looking for and keeps you glued and keeps you from churning. Okay. Now, Google also gets 3.5 billion searches every day, and it said that 50% of these searches are new, okay, which sounds also exciting. WhatsApp, right? So you and your girls, you contribute to 65 billion messages every single day. 65 billion. That's incredible. WhatsApp is the largest messaging platform with 2 billion users. So this is an exciting insight. In 2020, this year, there will be around 40 zettabytes of data. I think these two insights repeat themselves. 90% of the world's data was created in the last 2 years. It will take a person approximately 181 billion years to download all the data from the internet. Oh, that's really interesting. Okay, and there's a bit of something I wanted to highlight with regards to potential. In 2012, only 0.5% of the data was analyzed, and it hasn't gone up that much in recent years. Okay, 2019, internet users spent 1.2 billion years online. Interesting, right? And social media accounts for 33% of the total time spent online. So with what we've done with this text analysis, you can go back, connect to the Twitter API, generate some data, see what Ghanaians are saying, their sentiment towards certain topics. If you're looking for a job, you can do some of these things and then, I don't know, market yourself. Okay. So, and it's exciting. So I really do hope I encounter people doing some of these things, right? And
Twitter users send over 500,000 tweets every minute. I'm sure Trump contributes to half of that. Right? And this year, the big data market expected to grow by 14%, which ties directly to the next slide, which says that the job listings for data science and analytics will reach around 2.7 billion. Okay, so I have a background in geography, but that did not keep me from working on myself and in this field. So there are no limitations. So I encourage every one of you to put in your best, to work hard, and it will work out eventually. Look for mentors, look for people that can build you up, connect with people on LinkedIn, and then follow their learnings and what they are doing. Okay. So I wish you guys the best. I hope you had fun because I did. And keep learning, never stop learning. All the best.